Okay. So we need to introduce loops, correct?
Yep.
All right. That way I can give you the hard. Ifs are not loops. You said nested if loops. Those are not loops. They're loops mean you're just doing something multiple times. An if is a single condition. If this is true, do this once. A loop is if this is true, do this. If it's still true, do it again. If it's still true, do it again. Go ahead. I don't think so. I think you're ahead of me in Zybooks right now, right? Did I assign a chapter?
You want us to do up through 5?
Oh yeah, but you didn't have to turn them in. Just catch up.
Okay.
Is that what you're asking?
Okay.
Yeah. I just wanted you to have something to do in the meantime since I didn't get to loops last time. Okay, so let's open up Adam here and let's introduce loops. Okay, this is us, right? This is our beer test.
Oh, yeah.
All right. So for example, so let's just use this as an example. So this guy is an if statement, not an if loop. This happens one time. We've initially set the age to something. Then we ask one question. If the age is greater than or equal to 21, we print this out. Optionally, we can have an else and say, let's print this out instead. Okay? And that happens exactly one time. Now, let me ask you. So right now, what would the output of this be? Yep. So age starts off as 25. We ask, is 25 greater or equal to 21? It is, so it'll say this bud's for you. If we change this to 19, I run this again. Where did I store this? Is this on my... There's the come back later, buddy. All right, so now let's look at a couple little changes here. I'm going to go ahead and I'm going to remove the else here, like that. What would the output of this program be?
I mean, is there that space between them when they without factor?
All right.
Yeah.
So nothing. Prints nothing. Why does it print nothing? Age is 19, right? Is 19 greater than or equal to 21? No. So it skips the body of this if statement. How do we know that both of these lines belong to this if statement? Because they are indented underneath the if statement. So these guys, even though we have 10 lines between them, these guys belong to this if statement because they are structurally indented underneath it. Make sense? Come back here, run that again. Still the same thing. What will the output be now? Come back later. So by removing that indentation, this print statement no longer belongs to that if statement. He's sitting there on his own. He is his own logic. So we come through here. Age is 19, so we ask, is 19 greater than or equal to 21? It is not. That's false. So we fall past the if statement and continue on with our program on the next line, which is that print. So there's the come back later, buddy. Let's change this back to 22. What's the output of this program going to be? This bud's for you and come back later, buddy. Why? Age is 22. Is 22 greater than or equal to 21? It is. So we'll print out this statement. Program's still going to continue after that. We just situationally printed out this statement, or we conditionally printed out this statement. Then we continue on with our program with the next line, which is that guy right there. So now this is going to print out both, because that come back later, buddy, it does not conditionally occur. It always occurs. So there's both. If you want this to conditionally occur, you would have to use the optional else clause that belongs to the if statement. What's going to print out here?
Same.
Okay. I think this will actually give you an error. Yeah. It doesn't like that the else is empty. So you're correct in saying that this guy does not belong to the else, correct? Because he's not indented. Yeah, he's not indented underneath this. But Python says, look, if you're going to throw an else here, you got to put something in it. Otherwise, you're wasting your time putting it in there. So we can indent that, and now it belongs to it, right? So now this will be this bud's for you. And if I change this to 19, save it again, don't change the logic at all, come back later, buddy. Yeah.
If you decided to put the else in, I know it's useless, but if you put a continue underneath, would it run?
That's a good question. Continue is really just for loops, but it actually might break you out of this. Depends how generically continue is written. No. Yeah, needs to be in a loop. All right. That makes sense? If else makes sense? Now, we could, let's throw a little bit more logic in here, because there is something that the book throw an elif. Showed you that. Yep. So this is like an else if, in case you want to ask a bunch of questions all linked together. So let's say else if age is greater than 19 and, well, actually we could just say greater than 19. If it's not greater than or equal to 21, we're not going to say this bud's for you. If it's greater than 19, though, we're only going to get to this guy if we failed this. All right? Only one of these can fire. We're going to say, so close. Else. Come back later, kid. All right. So now we're asking two questions and then having a default answer. If you're at least 21, we'll say this bud's for you. Otherwise, if your age is greater than 19, we'll say so close. Else, we'll print out later, kid. So I'll change this to 20. There's the so close. I'll change this to 19. It should be come back later, kid. We'll change this to 22, and this should be this bud's for you. Now, how else could I have written this? We would call this the shortcut way of writing the if with a, and you could have a bunch of else ifs. You can say elif age is less than 4. Print. No, here. Where are your parents? All right, so you got a 3-year-old that waddles up to the bar. Where are your parents? That makes sense. You could put a whole bunch of else ifs in there if you want to ask extra questions. Now, I'm going to go ahead and take that second one out just so we don't confuse things. This would be the shortcut way of writing it. How else could we have written the else if? It's related to the nested stuff that you were mentioning a few minutes ago. Let's assume that I either didn't remember this elif shortcut dealy thing. What I could have done is I could have said else if that's true, else this. So now I have an entire if structure inside of the else. Does that make sense? So this code is equivalent. Let me back up here. I'll put them. I'll copy this and then put the other one beneath them and show you if these are equivalent. So this guy right here is the same logic as this guy right here. Go ahead.
So if you wanted to keep doing ellipse, you just keep like indenting and keep going down.
You mean if you're not going to use elifs, if you're going to use the longer hand version, yeah, you just keep indenting over and over and over again.
Okay.
So you can imagine how that gets messy, right?
Yeah.
When you're really not doing anything overly complicated, you just want to ask 4 or 5 questions. You know, you kind of have 4 or 5 different things that might happen in this case based on age, right? So the elif allows us to have the same logic but in a cleaner structure. Because Python cares so much about indentation, it's not going to let you get away without indentation. Now, one thing you could do is you can decide not to use tabs. Maybe you use 1 or 2 spaces instead of tabs, and Python will let you get away with that, but that only, slows down the inevitable, right? If you're writing your code such that you have things indented inside of things, you're going to eventually have stuff that's scrolling off the screen, which is fine. Python doesn't care about that. It's just going to make it harder for a human to read it. So elifs make sense in this particular case. Questions about elifs? So another tool in your toolbox. So you use elifs if you want to ask multiple questions. So we go back to our, we have our toolbox here at the bottom.
That way it saves us in Python file, and then it'll show up.
I'm going to go ahead and say more toolbox.
So
So we have conditionals. We have if, elif, else. Those are our conditional stuff. Now we're going to introduce loops. All right. So remember, we go back to how do human beings solve problems? We remember stuff, that's variables. We ask questions, that's conditionals. And then we use repetition. That's going to be our loops as well as our functions. So let's go ahead and let's write some loops. So if I want to print out the number 1, 2, and 3, I'm going to say print 1. Actually, we could just print out I'll copy this. Print 2, print 3. We'll go ahead and run that guy. So there's our 1, 2, and 3. Not too bad. So we all could write that. All right, so let's take 5 minutes. Everybody write something that'll print out 1 to 1,000,000. We see the problem, right? Right off the bat. Copy and pasting. We do 4, then print 5, then print 6, then print 7. Loops are going to be helpful.
Yeah.
All right. So if we're only going to do something a couple of times and we know how many times we're going to do it, maybe throwing it in a loop isn't worth it. All right. But if I want to print out 1 to 3, I can say maybe I'll create a variable called max count, and I'll start that guy off at 3. And then I'm going to say maybe I'll create a variable named I and start that off at 1. And we'll say while I is less than or equal to max count, we're going to do something. What are we going to do? We're going to print out I. And we're going to say I is equal to I plus 1. Run this real quick. There's our 1, 2, and 3. All right, so I created 2 variables. I'm remembering 2 different things here. I'm remembering what's the largest value I want to count up to in this case. And then I'm remembering what's my starting value. So I put that in a variable called I. All right? And then I'm going to ask the question. So this is a loop, but all loops have Boolean expressions in it. What's a Boolean expression? All expressions that boil down to a single value of true or false. All right? So just like an if statement, a while loop has a Boolean expression in it. That guy will boil down to true or false. The current value of I is 1. Is 1 less than or equal to the current value of max count, which is 3? It is. That's true. So we'll execute the body here. So we'll print out the current value of I, which will print out a 1. Then a 1 will become a 2. Spin back up. We ask the question again. Is the current value of I, which is 2, less than or equal to the current value of max count, which is 3? 2 is less than or equal to that, so we'll get into the body. We'll print out a 2. 2 becomes 3. Spin back up. Is the current value of I, which is 3 less than or equal to 3? It's equal to it, so that's again a true. So we fall into the while loop. We print out the current value of I, which is 3. 3 becomes 4. We spin back up. Current value of I is 4. Is that less than or equal to the current value of max count? 4 is not less than or equal to 3. Therefore, this is false. Therefore, we continue on with the program. Now we are here. Make sense? So there's our 1, 2, 3, then here. Shows us we went to the next line. And what's nice about this, if I want to print out all the numbers between 1 and 30, I just have to change max count. Now I got 1 to 30. If I want 1 to 300, now I got 1 to 300. And then we got our million number. That's a million, right? Now, very interesting. This is taking a while to run, isn't it? When everything else up to this point felt like it was instantaneous. Now I want to show you something here real quick. I'm going to take out the print statement there. And we're just going to count between 1 and a million. And then finally print out here. Okay? We're still getting into this while loop a million times. But instead of displaying it each time, I'm just going to count up from 1 to a million. That ran basically instantaneously, right? What does that tell us? It tells us that printing is expensive. When you display something on the screen, a lot of stuff is having to happen. Remember we looked at the Hello World assembly language program? What did we have to do? We had to load up some registers. This is just to print out Hello World, print out one thing. Okay? Loaded up some registers, called the kernel. So we stopped our program. Program left the CPU. It did some I/O stuff, spit it out on the screen, came back onto the CPU. Then we're going to load new stuff into the kernel for print 2. Leave the CPU, print out 2, come back on, get back onto the CPU, load the stuff up, leave the CPU, print 3. So on and so forth. Every single time we leave or get back onto the CPU, that's something called a context switch. You'll learn about that in the operating systems class, but punchline is context switching is very expensive, but it's also a necessary evil. That's how our multi-user, multi-programming operating systems work. If you want to have 3 different or 4 different programs minimized, you require context switching. You require your CPU to be able to switch between multiple applications. But because we just did a very small little I/O task, but we did it a million times, we were able to feel the context switching. So we weren't using all of our time on the CPU for this little thing. We were basically getting in, kind of like getting into a hotel room, unpacking one thing from your bag, putting it right back into your bag and checking out. And then coming right back in, doing it again. Not very efficient, right? It's not. Oh. So convenient.
Yeah.
I went through a very interesting problem-solving thing this morning with this tea. I drank it down to like 3 ounces off it. I was in the cafeteria this morning, and I decided, should I put like the fizzy water in there? You know how on the soda machine they have the water, but the soda water? Mm-hmm. And I did. I couldn't decide because I thought that would be kind of make like brisk tea, right? Isn't that's the Lipton brisk has just a little. The who? Lipton brisk tea. Yeah. Isn't that what it is?
This is Lipton brisk.
Lipton. Well, this is Lipton. This is Lipton brisk. This is Lipton brisk. See, mine comes in 48-ounce bottles. Not those little.
Does it taste good?
It's fine. Did it work at all? I mean,
I guess. Yeah, I don't know. I'm just not supposed to drink diet soda, so I'm just grabbing at straws here. So far, it's been pretty interesting. I've been off diet soda for about a week and a half now. Mm-hmm. I've lost 13 pounds, changing nothing else other than stopping drinking diet soda. Good. Well, at least not purposely not changing anything else. I think my body's just so depressed, it's just like slowly dying. I'm just starting to shed so I fit in the coffin. All right, so we get the while loop thing. So when do we use while loops? But for loops meet a conditional as well. So we come back here.
When we don't know this in the returns, or the times we want it to repeat.
Yeah, so types of loops. We have while loops. So these are what are called pre-check loops. That means they execute 0 or more times. There's no guarantee they will even execute once. All right, if I come back to my code here and I just change the value of I, well, let's shrink max count down a little bit. We'll put it at 3. And I change I to 4 at the very beginning. That loop will execute 0 times. Very first time through, we'll ask the question, is 4 less than or equal to 3? The answer is no. So we will not execute the body of the loop even once. We'll just print out here. So there's our here. So a while loop doesn't necessarily execute even one time because we check this, check the Boolean expression here before we execute the body. It's a pre-check loop. Make sense? And while loops lend themselves to problems where we do not know how many times we may loop. Now, we just used it for a counting type problem. So you can use while loops for basically anything you can use a for loop for. Mm-hmm. All right. But historically, a good example of a while loop would be something like when you get to something in a program that says press any key to continue, you don't know how long it's going to be till they press any key, right? You're going to be like, have they hit a key yet? 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 So on and so forth. It's going to keep spinning, and you don't know when that's going to occur. You have to spin a bunch of times. Okay? So those are the types of problems while loops lend themselves to. Then we have a for loop. This is also a pre-check loop. So similar in problem solving to a while loop. So this guy executes 0 or more times. Lend themselves. I notice here that I'm having a lot of difficulty with consistency in tense. I have themselves, I have pre-check loop, I have pre-check loops, executes and execute. Just keeping you on your toes. Yeah. Lend themselves. Just cover, lend themselves to counting type problems. Is that even a word, themself? I don't think that's a word. Now it is. Look at that. To counting type problems where we know how many times it will loop. Loops. It's 4 S's. Sorry about that. All right. So typically, if we're using a for loop in Python, we're going to use it in conjunction. Not always, but often we'll use it in conjunction with a function called range. Books introduce range?
Yes.
Okay. So let's throw that into our more toolbox stuff. So under loops, we have while, for. Let's leave it at that for a second. Now we have this function called range. Okay, and range takes at least 2 parameters and then optionally a 3rd parameter. So range takes start. This is start. I'm going to do inclusive. To stop exclusive. So if we say 1 to 5, it'll go from 1 to 4. So not quite including the 5. And then the last piece is step. Default is 1. So how much to increment the counter by each time. All right, so we'll look at a couple of examples of range here. Oh, it was in the book. Should be review.
Good. Do I need to write this
Did you do your Bible homework this week?
down? Yes, I did.
Are you lying?
No, I did on Wednesday.
I don't like him anymore. To be honest, I didn't really like him that much at the beginning.
Wow.
That's what gave it away.
It was the tattoo. I didn't like the tattoo. It's just weird. He's got this tattoo in his arm. I just thought
Well,
it
he
was
hasn't
weird.
had it the whole time. That's a newer thing.
Yeah, that's what I'm saying. That's when
Okay.
it changed. Remember my tip here. Don't judge a book by its cover.
Wait, what's that from? Oh, that's from Friday, right?
Yeah.
That's from Friday. Oh, that's right. Okay.
All right, so let's go look at range. So I'm going to say for I in range, and what we're going to do is we're going to say 1 to 4 as a starting point. This should do our counting to 3. Inside there, I'll say print the current value of I. So each time through here, this variable I will, the first time through will be a 1. Then it'll be a 2. Then it'll be a 3. Then it'll be a 4. Won't be a 4. Never be a 4 because it'll fail here. Go ahead.
So like, wouldn't it be the same if you just like wrote the value of I, so like I equals 1, and then just instead of doing 1 4, you just wrote 4.
Oh, what are you talking about? Tell me what you want me to type.
So like for like a say for instance, right, I equals 1, and then you say in range, or for I in range of 4, and then you just say like print I plus 4 underneath the print I, or no, you just write I equals.
All right, so I said I equals 1. What do you want me to do after this?
All right, so like underneath print, just write I equals I plus 1, and then erase.
Well, but this needs to be a Boolean.
Oh, all right, yeah.
Yeah, so anything you have in here has to ultimately map up to a Boolean.
Okay.
So you could do that, but you'd have to make it a Boolean check there.
Okay.
In fact, actually, let me check that real quick. Because I don't think because of how they intend for you to use this, I don't think you can say it's less than 4.
Well, I mean, you still use the in range. Like the range.
Well, in range isn't going to help you here.
All right.
Because range is always going to step anyways. You just said you wanted to increment inside,
Right.
right? Range will increment for you. That's what range does.
Okay.
Range says, here's the beginning, here's the end, and how much do you want me to change it each time? And I'll show you an example here in a second. I don't think this is going to work. Yeah, it's broken syntax for a for loop. All right, so for I in range 1 to 4, that means the first time through I will be 1, second time it'll be 2, then it'll be 3. It actually will become 4 the last time through, but then it'll fail the Boolean here because it's not in that range. It's not in the range of 1 to 4. I'll go ahead and print this out. This should print a 1, 2, and 3. There's my 1, 2, and 3. Now, the equivalent to this, there was like a hidden last part here. I'll just put a 1 in. That's how big to step. So I step from 1 to 2, from 2 to 3, from 3 to 4. I take steps of size 1. Make sense? So this will print out the exact same thing. 1, 2, 3. Now, let me go ahead and let this guy go up to 10. But I'm going to take steps of size 2. This will be 1, then 3, then 5, then 7, then 9. See how that last parameter, how that's used, that step parameter? This says how big do you want to step from. If you want to count backwards, we can go start at 10. If you want to go all the way to 0, we have to say go to -1, but not including -1. So, and then we'll step by a -1. So 10 will become 9, will become 8, will become 7, will become 1, will become 0. Then we fail the next time through. So this will count backwards. Make sense? Go ahead.
Does the range only include the integer only? Like the whole
Range is just for integers, but you can use it for other things. So let me show you another example. Yeah, so what range does is it generates a list of numbers. I'm pretty sure we can do the same thing here. I can do 1, 17, 22, 44. So 1, 17, 22, 44. So now I'm saying this loop, each time through, I is going to be one of these elements. And we're going through in order. So the first time through, I was 1, we printed out 1. Second time through, I became 17, we printed out 17. Then 22, then 44. See how that worked? So I gave it a collection of stuff. In this case, I gave it a list of numbers. And I said, I want I to be each element in there each time through the loop. Range will effectively generate something like that. So if I say range 1 to 4, it will generate that list for me. That's the output of range, effectively. Similarly, you could put a string in there. String is a collection of chars. So there's the HELLO. So you can spin through every character in a string. If I want to, now, I don't have to call this guy I. I can call this guy LOL if I want. Just whatever I name him up here, I have to use him by that name down here. Make sense? Now, what if I wanted to go through this string hello backwards? Well, here. Let's say I want to go through whatever is in S backwards. Without, has the book introduced the reverse function?
Yes.
Not allowed to use the reverse function for the next 5 minutes.
Next
So,
minute? Oh, okay.
just 5 minutes. I want to go through, let's say you don't know about the reverse function. How do I go through whatever string? I'll tell you that there is a string in S, but you don't know what string it is, so pretend like you don't see the line right before it. All right? I want to go through S in reverse and print out each character that's in S. How many characters are in S?
About 5.
We look at strings. You mentioned you have a function called reverse. You also have a function called length, len, and that guy returns the number of characters in a string. So how many characters are in S?
Only just that one character.
The length of S will be the number of characters in S.
It'll just be one character.
Well, not one
Oh,
character.
wait, I mean,
So I can say for I in range, and I'm going to start at the last legal bucket in my string. So if a string happened to have 5 characters in it, the legal buckets are 0 to 4. So I'm going to say the last legal position in S is length of S minus 1. And I want to keep going up to but not including -1. So I want to go all the way to bucket 0. And I want to take steps of size -1. Then each time through, I'm going to print S at position I. So we'll go ahead and run this real quick. Oop. So there's hello in reverse. So let's look at how that worked. We'll just shadow it a little bit up here. So the length of S, if we happen to know that S was hello, the length of S is 5. But the last legal position in S is actually 4. So I want to start my count at 5 minus 1. We happen to know in this case that that will boil down to the number 4, correct? So we're going to start our count at 4. I want to keep going as long as my count is greater than -1, because that's exclusive. So we won't actually get to -1. We'll stop at the number right before that, which because of the way we're going to count will be a 0. And then the size of steps I want to take is going to be -1, because I'm going through backwards. I'm going to go from 4 to 3 to 2 to 1 to 0, including the 0, because I said stop at -1. That makes sense? Then each time through, I said, go ahead and show me the character that lives at position I in my string S. So the first time through, that was O. Then it was the L. Then it was that L. Then it was that E. Then it was that H. Make sense? So this is the position I'm starting from in range, including that value. This is where I'm going to stop, not including that value. And this is how I'm going to step. If I want to step backwards by 2s, I'll print out an O, then I'll print out the second L, or actually the first L, then I'll print out the H. Because I'm actually taking double steps as I'm changing the value of I. So as a general rule, we kind of give ourselves a general rule for for loops. Call it rule of thumb. Take a variable, for example, on I. Usually we kind of use like a throwaway variable.
Mm-hmm.
So I, J, K, your common for loop variables, just because that's, common programming says your first loop should have an I in it. Then if you have a loop inside of a loop, then you use J. If you have a loop inside of that, then you use K. Humans can kind of only go up to 3 dimensions, but hey, if you just want to keep putting loops in there, then start making up variable names. Okay, but in any case, so rule of thumb: take a variable I on a journey between values in a range. For example, the indexes of a string. If we have a string hello, we might want I to be 0, 1, 2, 3, and 4. Potentially not in that order, but because we might want to access the individual positions of that string. So as a general rule, when we're using for loops, this isn't, you can use for loops to do different things depending on how you want to kind of bend the syntax to your will. But as a general rule, a for loop is taking some variable through a range of values, and then we use those values to do something with them. If you just want to go through the characters of a string, the values you're going through are all the characters of a string. If you want to know where in the string you currently are, you might want to go through the indexes of the string. 0 to the length of the string minus 1. And then if you need to get the individual character there, then you can say the name of the string, and then the square brackets gives you the value that lives there. That makes sense? All right, so that's kind of typical uses of a for loop. And then I want to make sure is there is a do while loop, right? Did you guys see a do while loop?
Do while?
Did you see that in the?
No, not yet.
Okay, I'm not gonna show you that. Okay. I actually think it's different in Python. I think it's just something that's called repeat. Maybe not. We'll figure it out. Anyways, so now that you know how to do the looping stuff, and we know how to do string concatenation stuff, and we know how to do division and modulo stuff, now we can do the homework. So we're going to start off by, so we'll do kind of a simple first one, and then we'll make it a little bit more difficult. So we're going to go ahead and write the code necessary to convert a decimal value to binary and display the binary answer in the correct order. So remember, if I want to take like the number 42, I divide that by 2. That's going to give me 21. 21 times 2 is 42, so I have a remainder of 0. 21 divided by 2 is 11. Not 11, it's 10. So that's 20, remainder 1. 10 divided by 2 is 5. 5 times 2 is 10, remainder 0. 5 divided by 2 is 2. 2 times 2 is 4, remainder 1. 2 divided by 2 is 1. 1 times 2 is 2, remainder 0. 1 divided by 2 is 0. 0 times 2 is 0, remainder 1. And we're done. And then we read our answer from bottom up. So that's 1, 0, 1, 0, 1, 0. That's the answer your program should output. But you can hard code, you could just write say variable x is equal to 42. And then write the necessary functions, or not functions, write the necessary for loop, probably, to divide that, or actually while loop. Yeah. Are you allowed to use the what? The bin, there is a bin function that converts it? Yeah, don't use that. You gotta do modulus, do the double slash. So here. So use while loop mod that guy. That should allow you to do it. Your next homework is going to be to convert a decimal to base. So if you wanted to make this more generic, or if you decided you really wanted to use the bin function, you just change the 2 to an 8, and now all of a sudden it's an octal. Or if there's an oct function, then just change the 2 to a 6. There's probably not a base 6 function. So it's the exact same logic. Make sense?
Yeah. Are we required to sign up for the?
Yeah, hackathon is is it April 14th?
I'm pretty sure.
That's right. So what's March 22nd? That's the CS get together.
Yes.
That's like 2 weeks.
Yeah. So April 14th, I'll talk about it next class. Remind me at the beginning of class, I'll put it up. But you want to email Professor Josh Locklear to sign up. All my classes are required to do it. I put that up on Slack, I think, right?
Yeah, that's what I was asking.
Yep.